Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about LINQ. This is a way for you to do queries on your collections in C#, kind of like the same as you would do with some databases. So if you already know something like SQL queries, then this is actually going to look quite familiar. Okay, so here let's learn all about LINQ. If you work with databases or simply do lots of data queries, then this is going to be extremely useful. LINQ is really just a collection of functions that works with collections of data. Importantly is how that collection of data can be almost anything. It works on lists, it works on arrays, it can work on databases, XML documents, and a bunch more. It works on anything that implements IEnumerable or iQueryable. Since lists and arrays already implement those, let's use a nice list for testing. So here I've got a simple player class, just has a string for the name and a team. Then I've constructed a new list and constructed a bunch of players. They got different names and they're on different teams. So right here, this is our data. Now we want to do some kind of query on this data. For example, we want to grab just the players on the red team. Now, one way to do this is obviously by doing a simple for each, cycling through this list, then construct a brand new list, and inside the for each, check out inside the list which one has a team equals red, and if so, add them to the other list. So yep, that would work perfectly fine, but we can also do it somewhat more simply by using LINQ. First thing is we need to go up top, and we need to add the LINQ namespace, so using, and it's inside system, and system.LINQ. Yep, that's it. This is the namespace that has all of the LINQ functions. So now, for example, down here, if we grab the player list and just write a dot, so this right here is the normal list of functions. So this is the normal list functions. And then over here on the sides, these are the function extensions. Most of these are actually LINQ functions. This is how LINQ is super easy to use. It is all based on extensions upon other types. So if you have any kind of collection, you can always find a lot of these functions. Now in this case, we want to do the simplest thing possible. Really just query this data for one specific condition. We just want to grab the elements where the team is red. So over here, one of the things we can do is use a where clause, and this one is like the name implies. It's going to select some objects where this condition is true. This one takes in a predicate, which is really just a func, so just a delegate. It takes in a player object as an input and outputs a boolean. So basically, if this output is true, we are going to select this player, and if it's false, then we don't select it. Now in this case, we want a very simple delegate, so we can just use a very compact length of expression. We can define the player, then our little arrow, and then for the condition, in this case, we want just player where the team equals red. And if that's it, super simple, this is our delegate, so this is going to do our conditional logic. And now this function itself, this one is going to return an IEnumerable. So if we want, we can just do a for each directly on this. Or if we want a more, let's say, standard type, if so, we can call something like either toArray or toList. Like the implies, that will convert it to either an array or a list. So let's put this inside a list. So let's define a list of player type, call it the red player list, just like this. And yep, so here we have a list of our red players. Let's actually verify it. So let's do a for each player in the red player list. Cycle through all of them and just do a console.writeLine, do a log on our player. Okay, let's test. And if there it is, it found CodeMonkey and Black Widow both on the red team. All right, awesome. So in this super simple example, you can already see how LINQ is quite useful. Instead of having to do a complex cycle, having to make a brand new list to store all of our selected elements, instead of all of that, we just have a single line of code. And in this, we automatically query for all of our elements based on our condition and make our final list. So LINQ really is quite easy to use. If you want to do tons of data queries, then this is going to be much easier as opposed to using tons of for each with tons of conditions. Now inside, we've got the where, but we have all kinds of things. So here we can inspect all the operations we can do. For example, all. This one returns a boolean and determines whether all the elements satisfy a certain condition. We can do any to check if it contains any elements. We can grab just the first element of a sequence. We can grab an intersection between two groups of data. We can join them, we can grab the last, and so on. So as you can see, tons and tons of functions to do tons and tons of operations. And LINQ also has one very interesting thing. So we can do this. We can just run the normal LINQ functions. This is the LINQ method syntax. But there's actually another way. There's the LINQ query syntax. Now, if you know SQL, then this is actually going to look quite familiar. The query syntax, that one returns an IEnumerable. So let's make an IEnumerable of type player. So red player IEnumerable, okay. And now after the equals, instead of writing normal code, so first grabbing the list, instead of that, over here, let's write the from keyword, and then we give the individual element some name. So in this case, we're cycling through player, so let's call it player. So this is going to be our local variable that is basically going to cycle through everything. And then in, and then we select the collection of data where we want to work on. So in this case, that's going to be our player list. And then we can do all kinds of operations. So once again, we can do a group, we can do a join, we can order, select, switch, and so on. In this case, we want a simple condition. So let's go with where. Then our condition, let's do the exact same thing. So where player.team equals red. If the player's on the red team, then we want to select it. So let's just select this player. And yep, that's it. So this code over here is basically going to do the exact same query that we did up here. The only thing missing is really just the tool list. But here we have the IEnumerable, and if we want, we can then convert this into a list. But in terms of the condition itself, yep, these are doing the exact same thing. So this one grabs the list as the input, then cycles through the list and grabs each element and calls each element player. Then for each one, it runs this condition, checks if it is true, and if so, then simply going to select that element. So if you're familiar with SQL, then you're basically familiar with this. Here what we have is essentially, let's say, a select everything from some kind of player list database where the team equals red. So this is some basic SQL, and right here we have pretty much the exact same thing, but written in the LINQ query syntax. Let's just verify it and make sure that it says the exact same thing. So let's cycle through this one. And if they're the same thing, it did find both of them. Okay, great. So yep, these are the two methods for working with LINQ. We can either use normal functions or we can use the special query syntax. Now, one very important thing about LINQ, it's how up here when defining the query, this line of code, this one isn't actually doing anything. This one isn't actually creating any new list or any new elements. It isn't actually running any kind of conditional logic. This line over here, all it does is just define the query. That's it. This one does not execute the query. The query is only executed down here on the for each. When cycling through all the elements of this IEnumerable, that's where it runs the logic for checking the condition, selecting, and so on. Meaning that LINQ has deferred execution. Writing the query, this one just defines it. It does not execute it right away. Only later on, when actually cycling through the collection, only later on does it actually execute the query. Now this can be quite important if you're limited in terms of performance. You can safely create the query pretty much whatever you want, and then you can wait until later in order to actually run the query. Or if you want, you can actually run it across multiple frames. So IEnumerable, you can manually get it whenever you want. It doesn't have to be inside of for each. So you could run this over multiple frames, which could be helpful if you're cycling through a massive database. Although also another quick note, which is up here when using this method. When using this one, same thing, it is not going to execute just to find the query. But when we call toList, naturally this is indeed going to run the entire query right away and put it inside a list. And like I said, LINQ works with just about any collection type. So here we're working with a list. This one would also work with some kind of array. It would also work with, for example, something like XML. So for example, if we have some kind of list of contacts, if so, then we can define a query going inside it, inside some kind of record node, then inside grab some kind of field, check if the field value does match something, and select that contact. And yep, this is perfectly valid code. All right, so that's LINQ. It's an interesting way to do queries on collections of data. In many cases, it can actually be simpler than doing normal cycles by normally going through a list and testing for some conditions. The only downside is it can sometimes be expensive in terms of memory and performance, but when not doing anything super performance critical, in many cases LINQ is a great way to do quick queries on all your data. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about WinForms. This is how we can build visual applications in Windows. If you just want a quick and easy way to make something visual, then this is really great. You can just drag and drop all kinds of controls like buttons, scroll bars, labels, and so on, and everything is pretty easy to use. Then of course, all the C# code that we'll learn throughout this entire course, all of that works on any of these controls. Okay, so in this course, we've been mainly using console apps. They are great for focusing on the code itself, but sometimes you might want to build something a little bit more visual, something with a proper UI. And for that, for making visual applications, we have two main options. There's WinForms or Windows Forms and WPF or Windows Presentation Foundation. Those are the two main ones. In order to be able to use them, we need to first install the modules. So open up the Visual Studio installer, and on your Visual Studio installation, let's go and modify it. Then over here under Desktop and Mobile, here we do see .NET Desktop Development. So you can see build WPF for Windows Forms and console applications using C# and so on. So yep, make sure you select this one and install it. In my case, I've already installed. And now if we open up Visual Studio and let's create a brand new project. And yep, right here we do see the things that we just added. So right away we have the two main ones that I mentioned. We've got WinForms or Windows Forms and WPF. Now for these two, WinForms, this one has been around for ages, pretty much for as long as .NET has been around. So it is very mature technology. Whereas WPF, this one is newer and has some more advanced graphics capabilities. They also have some very different architectures. WinForms, this one is very lightweight and very easy to use, while WPF is quite a bit more complex. Also, by the way, I should mention these are not the only two options. For example, one limitation of WinForms is by default, it only runs on Windows. So for cross-platform development, you have something called .NET MAUI. By the way, you might somewhere see the name Xamarin. That's what this used to be called, but Xamarin has since turned into .NET MAUI. This one is cross-platform, so you can write your code and then you can deploy it onto iOS, Android, macOS, or Windows. And also, just another quick mention. Remember how even though Unity is a game engine, that does not mean that it can only build games. You absolutely can build normal applications in Unity. Unity is really just a rendering engine. For example, I've built a controller module to control my live stream overlay. This whole thing, this is really made with Unity, even though it's really just a menu with some buttons. I've also previously built a launcher to launch all my games, so just remember how you always have that option. If you're already familiar with Unity and you want to make some non-game app, then perhaps using Unity might be a good option. But over here, when it comes to WinForms versus WPF, WinForms is really great for its simplicity, and WPF is great for more serious visuals. But like I said, if I'm building something based on visuals, I'm just going to use Unity. So for making non-Unity apps, let's learn a little bit about WinForms. Now to create, we want to create the template. However, it is not this one. Remember the whole thing that we saw in the beginning of the course? This one is using .NET Framework. That is not what we want. So up here, let's search for Windows Forms. And if we see one without .NET Framework and one with it, so it's this one over here, the one without .NET Framework. This is going to be the latest .NET version. So let's go ahead, select this one. Now let's give it some kind of name. So WinForms C# Core, something like this. And let's click on Next. Then for the framework, yep, let's go with .NET 8. And yep, here it is. And right away, we actually do see a difference. So instead of the code that we saw right away on the console app, instead of that, now we see a visual window right away. And if we try running this, yep, there it is. Here we have a standard Windows window. All right, awesome. So on this, you can build whatever visual program you want. On the right side, we have over here the toolbox. If we go under all the controls, yep, here they are. You can see all the tons of elements that we can add. So for example, we can add buttons, we can add checkboxes, we can add a datetime picker, we can add some fonts, we can add a label for just some text, we can have a list view, just a panel, just a picture, and so on. So basically all the elements that you're used to in any kind of Windows program, you can all find them here. Let's do something very basic. Let's just take a button. So let's click and drag the button and drop it over here on our visual window. And yep, there's our button right here. Now here we've got the usual controls that you find on pretty much any visual program. So we can move it around, we can scale it, and so on. Then also on the right side, we do find over here the properties window. So this is kind of like the inspector inside of Unity. Here we can customize this object. We can modify pretty much anything. You can modify the font, the color, the text, and so on. So here, let's change the text right here. Instead of saying button 1, let's say click me. And then another very important one is to give it a proper name. So instead of button 1, let's name it the click me button. And yep, there it is. However, if we run this, there's our button, a normal Windows button. We can mouse over and change it and so on. And we can click, and it does work. We can click, but nothing happens. So let's give it some behavior. With the button selected, over here up top, we see these two little things. So this one over here is for the properties, and this one over here is for events. So here we can see all kinds of events. Now, WinForms, this is really all based on events. So you'll listen to a bunch of events like mouse click. And when that happens, then you can do some kind of logic. So you can hook onto any of these events. As you can see, there's tons of them. The simplest one is really just a click. So here you can write some kind of name for a click event function, or you can just double click for default. And if right away, it opens up a view with some code. So here we've got our event. So as you can see, standard event, so object and event arg. Here we have the event where we can write whatever we want. Now, just make sure you don't modify the code up here. This is the forms constructor. This is what actually runs and sets up the form with all the visuals. We can actually inspect over here the initialized components. So let's go to the definition to see. And up here is all the code for initializing and creating the form. You can see here we are constructing a brand new button. Then it is setting the button location, the name, size, and so on. And then down here, setting up the form itself, setting up the dimensions, the size, the name, text, and so on. So really what we are doing here in this visual interface, all of that is really being converted into code, which then actually creates our form. Okay, so here on the Form1 code, when we click, let's just fire off a normal Windows message box. So for that, we go inside the message box class, and let's just call the show function and then show something. Okay, yep, just like this, super simple. This will show a message box with some text. So let's go ahead and run. And okay, here's our button, and I click. And if there you go, here's our nice message box. Okay, great. So this is really the basics of WinForms. You've got over here visual design. You've got your toolbox with a bunch of stuff. You really just drag controls and add whatever behavior you want on it. Now let's just see how to do some logic between events. So let's drag something else. Let's drag a label. So this is really just some text. So there you go, just a label. Then here on the label, again, the properties we can modify with all of this. For example, we can change the font. There you go, I just use a random font. We can modify the border style. We can modify the cursor. So let's make it with a nice hand cursor. For the border style, let's make it fixed 3D, just like that. For the padding over here, let's increase it by a bit. And that's it. As you can see, we can modify pretty much anything on our object. And up here, we also do see some events. So again, we can add anything that is going to happen whenever we interact with this label. For example, we can add some logic on click. That works perfectly fine. But now let's say we want to click our button, and on the button, change the text on our label. Now first, let's also just make sure that over here the name has a proper name. We're going to modify the text dynamically, but for the name, yep, here it is. Let's call it our text label. Okay. And now the way we access other objects is actually quite easy. We can look here on the code where we are initializing our form, and we can see, okay, we have the click me button, and over here we have the text label that we just created, and has all the setup that we just made. And as you can see, this one is a text label, meaning it is just a simple field that is defined on this class. And this class, note how this one is a partial class, and the other one where we have our click code, this one is also a partial class. Both have the exact same name, meaning both are part of the exact same class. So to access other objects, we really just use the name, because again, this class shares the other class, which share the same field. So in this case, we named it our text label. So yep, here it is. There's our field, our text label. And then inside we can do whatever we want. So for example, let's change the back color. Let's call it color dot, let's say Sandy Brown. Then text label, let's change the for color. So this is the text color. Let's put it color.white. And then for the text label, let's modify the text itself and say, hello and welcome, I'm your code monkey. Okay, yep, that's it. Super simple. Let's test. And here we are, and there's our label. And by the way, as we mouse over, the cursor actually changes, so that's fun. Now we can click on click me, and there's the box. Click on OK, and yep, there it is. There's our text. All right, awesome. So you can see on a mouse click, we easily changed a bunch of properties on a different object. Now also here we saw one interesting thing, which is over here, it's like this by default. And when we click on this, yep, there you go. Look at this. It did not change the text right away. That is because this message box over here, this one is actually blocking the program execution. So the code over here basically stops when it gets to this line and only continues executing the rest of it when we finally dismiss this window. Basically, this is now pausing the main UI thread, and when we click on OK, that one resumes and yep, continues running the rest of the code. So this is where things like asynchronous programming become really important. It's so you can do all kinds of logic without blocking the main UI thread, which then is going to update the visual. Alright, so that's the basics of WinForms. This is how you can very easily and quickly build a visual window application. It has a very intuitive workflow by just dragging and dropping some controls. And of course, all the C# code that we learned in this course, all of that can be used with any of these visual elements. So if you want to make a quick, simple visual program, then WinForms can be a great option. But also remember how Unity doesn't have to just make games. So if you want to make non-game apps, if you want something visual, you can also just make a simple Unity window. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about DLL import and the extern keyword. With this, we can interact with external libraries. So we're going to see an example of how to interact with the Windows API. Okay, so while building our program, sometimes we might want to interact with an external DLL library. In order to call that external code, it's actually quite simple. As an example, we're going to see how to interact with the Windows API. So first we need to know exactly what we're going to be working with, meaning that we need to know the exact function signature. So one excellent place to see all the functions inside the Windows API is this website, pinvoke.net. This is a great resource that shows all the libraries and all the functions. So over here on the left side, we can see all the various DLLs. For example, we're going to be working a lot with user32, or alternatively, you can also see all of that in the Microsoft documentation. So for a simple test, let's do a simple Windows beep. So for that, we have this function called message beep. This one exists inside the user32.dll library. And right away on this website, we can actually see the correct syntax. The function is going to return bool. It is called message beep and has a beep type, which is actually, we can see down here, it's a uint, as a uint named utype. So we just need to write exactly that. So over here in our code, let's do that. So make it public, make it static. We're going to return bool, and it's called exactly message beep, like this. And inside we have a uint for the utype. And yep, just like this, except of course, like this, we do see this error. It is telling us we must declare a body, but it also says here that we must declare a body because it is not marked as abstract, extern, or partial. And the way we're going to solve this is by using the extern keyword. So over here, just type in extern just like that. And yep, the error is gone. Basically, extern, this one says to the compiler that this function is external, meaning it is not defined anywhere in our program, but rather somewhere else. And now that it is marked as external, now we need to specify exactly where is it. So that's where up here we're going to use the DLL import attribute. And this one exists inside of this namespace, system.runtime.interrupt services. So use this one, and this one takes in a string for the DLL name. In this case, it's user32.dll. Yep, just like this. And yep, we have no more errors. So as you can see, it's quite simple to work with external libraries. The only important thing is really you just need to make sure to write the function signature exactly. So now for testing this, we really just call it like a normal function. So over here, let's just call message beep. And let's pass in the default one, so just 0. Okay, so let's run this and see. And yep, there's our beep, there's our sound. So we defined an external function and we called it. All right, awesome. So yep, here everything is working. And like I said, the function signature, this has to be absolutely exact. If we give it a different name, like just 1e, if we do this like this and call it, right now we see no errors. But if we try running this, Yep, of course, we have an error. It is saying entry point not found. Basically, did not find any entry point named exactly message beep. That is because the proper one has 2 E's. So again, you can refer to over here on pinvoke to see all of the various functions we can call. You can see the exact signature. So as another example, let's use the message box. So here we see the signature for this one. Or again, we can just look at the official documentation right here. We can see all the parameters, and over here on this documentation, we can also see all the various values. The only thing is over here on the official Microsoft, this one says our C++ code, whereas over here in pinvoke, we see some proper C# code. So let's copy exactly this. So here we are, and let's paste it, so same thing. So we've got the DLL import, and just has some extra parameters. Then this one is again, it's static, it is extern, it returns an int, it is named exactly message box, it has a pointer for the window, then it has a string for the text, another string for the caption, and a uint for the type. So yep, now let's just call this. So over here, instead of the beep, let's call our message box. For the window, let's leave it on 0. For text, let's say hello world. For the caption, let's say CodeMonkey. And for the type, let's just go with 0. Okay, so let's try this. And if there it is, look at that. Here's our window, our title, our text, and our OK message. Okay, great. Now let's play with this a little bit more. Here on the Windows documentation, we can see the utype. This one is actually a very special thing. It says here this parameter can be a combination of flags from the following groups of flags, meaning this really enum flags or really just a bit mask. We already learned about those in the bitwise operators lecture. So here we can just select a bunch of these options. For example, we can have abort, retry, ignore. We can have those buttons, or cancel, try. We can have OK, OK, cancel, or yes, no. So for example, let's say we want yes, no. So here instead of 0, let's put yes, no, just like that. But this is a bit mask, so let's also use another one. So for example, over here we can see a bunch of icons. So let's go with this one, an icon with a question. And since this is a bit mask, let's make sure to use the OR. Again, the bitwise OR, just one pipe, just like this. Yep. So this should say the exact same message, but now it should have yes and no buttons, and it should have a nice question mark icon. So let's test. And if there it is, exactly like that, question mark, yes, no, absolutely perfect. All right, awesome. Now, if you want another example, you can watch my transparent Unity window tutorial. This is exactly what it sounds like. I made a Unity window with a transparent background. And the way that works is, again, by using some external function calls. So using that, I was able to make the background transparent. That's how I'm able to make this live stream overlay of the characters in chat walking around. This whole thing is a transparent Unity window. And another thing similar related to this one is called library import. This one is also an attribute. This is actually the newer method for doing this. It has improved performance and compatibility. The only thing is it requires source generation in order to work, but nowadays most projects will probably support source generation. In order to use it, in terms of the code, it's actually mostly the same. So in here, instead of using DLL import, we use library import. And since this is based on source generation, instead of using extern, we use the keyword partial. And if we make this function partial, if so, then we need to make the entire class partial as well. And again, make sure we have the exact same signature. And this one is telling us that we need to use the marshal as attribute. Marshalling is basically the concept of interoperating data between managed and unmanaged data. So in this case, we just need to add the attribute to define the return type, marshal as unmanaged type.bool. That is this boolean type, make sure that it works. And if that's really it, we have no errors. And if we call it, call message beep, and yep, we still have the beep and we still have our message box. So this is another alternate method for also calling external code. Alright, so that's DLL import, extern, and how to work with the Windows API. With this, you can actually do some really interesting things. Like for example, you can show a message box or open a file dialog window. You just call those functions, you don't have to build those windows from scratch. Or you can build a transparent window like I did. The Windows API is really huge, so definitely feel free to browse it to see everything it can do. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to use asserts. This is a very interesting code validation tool. And then we're also going to talk about unit testing in general. Okay, so asserts. This is an interesting way to make your code much more robust and free from errors. It is really just a simple way to test for something. This way we can easily validate our code to make sure everything works exactly as expected. For example, here is a player class, and on the constructor we receive a string for the player name. Now let's say the name is never ever supposed to be null. Basically the rest of our code is making the assumption that player name is never null. So we want to make sure that rule is enforced. Basically if that happens, then it's an error in the code that should never happen. So we do want to know if it does happen. And one way to do that is with an assert. Now they exist inside the debug class. This one inside system.diagnostics. Inside we can call the assert function. And this one takes in a condition. We want to make sure this condition is true. So in this case, let's make sure the player name is not null. And yep, just like this, very simple. So now up here, if we construct a brand new player, if we do this and we pass in a valid name, so a proper name, if there it is works, nothing happens. Whereas if we pass in with null, if there it is, our code basically just stopped. Now importantly, this is not an actual error. The program did not crash, it is still running. Instead, it really just paused. So this assert really just acts like a breakpoint. That way we can use our debugger tools in order to figure out exactly what happened. And then if we want, we can click on continue to continue running the rest of the program. And if it continues, terminates, and so on. So basically asserts help you ensure that certain conditions are true. If it is not true, the program will pause. Now one extremely important thing is how asserts are meant for validating code only during development. This is not meant to be used during runtime. In fact, by default, this won't actually even run during the final build. It has to do with up here for the configuration manager for the various configurations. By default, this one, debug.assert, this will only run if you have the debug configuration selected. Now, I talked about these configurations a little bit more in the lecture on preprocessor directives. So like this, if we select debug, the assert will run, but if we change this to release, this is what you would normally do when making the final build of your game. If so, then even if you pass in the wrong data, if you pass in null over here, nothing would actually happen. If you don't have the debug configuration selected, then it's as if this line of code does not exist at all. It is completely not included in the compilation. So keep that in mind. The goal with assert is to ensure your code is behaving exactly as it should be during development, and then after you verify that everything works, then you make a release build. If you do want to make some verification logic during runtime, for example, in this case, let's say the player name was a user input instead of a hard-coded string by a programmer. If it was a user input, then you would not use this. If it was user input, you would make a simple if. So if player name equals null, then do something. So do remember that point. The goal with asserts is to validate your own code, and then you can use regular logic to validate runtime code. Now, if you do want to do asserts in runtime, there's actually a way. So over here, debug.assert, like I said, this line will not be included in the compilation if up here we have release selected, but we can use trace.assert, and this one does pretty much the exact same thing, but this one is included in release mode. In general, that's really all asserts are. You just have a simple condition. You add these in various places in your code to make sure your conditions are always true, to make sure the code is running correctly. And if something goes wrong, then you simply know about it so you can fix it. Now, since asserts are all about testing your own code and making sure that it behaves as intended, let me just briefly talk about code testing, or specifically unit testing. This is a huge topic, so I'm just going to briefly mention a high-level overview. So when doing unit testing, that is when you write a bunch of tests to ensure your code behaves exactly as expected. So for example, over here for this player class, let's assume the player should never be null, but then let's also say this one doesn't make that assumption, it just stores the player name. And then let's have some kind of function, so get player name length, and this one just goes inside the player name and returns the length. Now naturally, if over here the player name is null, then this one is going to throw an exception. So if this was our player class and we want to test this, then basically just come up with a bunch of tests, a bunch of edge cases where your code could go wrong. Like for example, up here, define a player class, player, set it to null, and then call player.getPlayerNameHello length. You would put this whole thing in some kind of try catch. And if it throws an exception, then simply we have the test failed. And if not, then test succeeded. So let's test. And yep, this one throws a null reference exception. And we can see indeed our test failed. So this is a basic example of a test. You set up everything to run the test, and then maybe it succeeds or maybe it fails. And if it fails, then you know you need to fix something. So you do that, you would fix that. Like for example, up here, you would add if this one equals null. If so, then set it to an empty string. And if now with that change, now the test does succeed. So this is really a very rough high-level overview of unit testing. You have a unit, meaning some piece of code. It can be an entire class or just a function. You have that, then you write some tests to test whatever you want. In this case, testing what happens if the player has a null name, and then we try getting the player name length. So you write all your tests, and then if all the tests pass, then the code is good, and if something fails, then basically you have some work to do. Then in order to write these tests, technically you could do it all like this, build it all from scratch, but there's a bunch of testing frameworks that can help simplify that process. The official one by Microsoft is called MS Test. There's a pretty simple guide here on how to start using it. So basically you have some kind of code that you want to test, then you create some kind of test project. You create a class that is going to test a bunch of things. For example, we test over here that number 1 should not be prime, so it makes some assertions, there's a bunch of things. And instead of having to write all that try-catch code that we just saw, it really just works based on adding a bunch of attributes. So using a testing framework like this can make it much easier to make some tests. Two other very popular testing frameworks for C# are, one of them is NUnit, and another one is called XUnit. So if you want to do unit testing, it is probably wise to use a proper testing framework. Alright, so that's asserts. It's a way to validate your own code and test your own logic during development. This way you make sure your code is running exactly as intended before making the final build. And here we also covered a high-level overview of unit testing, what it is, and the various frameworks you can use. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to write unsafe C# code. This lets us disable the safety features of C# so we can access raw memory and do anything we want with it. Okay, so let's see how to write unsafe code. Now this is a very advanced topic. When working with raw pointers, it is extremely easy to mess up. You can corrupt some memory and crash your program, or you can simply end up opening your program to all kinds of security vulnerabilities. So this lecture is very much just a quick introduction to the topic, just so you know that it exists. I myself am not an expert in unsafe code. I've never really used it myself in any serious project, I just know that it exists. In order to properly use unsafe code, you need to know exactly what you're doing. If you don't, you're going to cause a lot of trouble, so always keep that in mind. Now, before we cover unsafe, how exactly is C# safe? Well, C# actually has a ton of safety features, mainly to do with memory. For example, when working with a language like C, when you want to create a brand new variable, you need to manually allocate some memory for that variable. Whereas in C#, that is all handled automatically. So if you define an int I equals something, this automatically defines the memory for this integer and automatically assigns the value. Then when reading some memory, like for example a string of text, you need to know how far along to read. You need to read it character by character. Whereas again, in C#, you just got a string with something, and then you can easily read it and say something to it. When working with pointers, you can have pointers to invalid locations in memory, whereas in C# you simply have null. So that and tons more things. Basically, C# tries to protect you as much as possible. And of course, the downside of all of these safety features is naturally it makes the code a little bit slower to do all of these safety checks. That is why, in super performance-intensive applications, usually you write it with C or C++. For example, while you write game code in Unity and C#, while you do that, the engine itself, that one is mostly written in C++. The entire engine has an entire pipeline to basically have your C# code communicate with the backend C++. And the reason why it's in C++ is exactly to have access to all that raw power without that safety overhead. But again, the engineers that work on the Unity backend, they are experts, which is why they can work with pointers without causing all kinds of issues. Now, in C#, in order to write some unsafe code, it's actually pretty simple. You just use the unsafe keyword. Now you can mark an entire class as being unsafe, you can mark an entire function as unsafe, or you can simply define a code block, and just this code block is marked as unsafe. Now inside of this we can write any unsafe code, like accessing pointers and allocating some memory. Although right away you can actually see an error. It is saying unsafe code may only appear if compiling with the unsafe. So we need to first set up the project to actually support writing unsafe code. By default it does not support it. So for that, let's go onto the Solution Explorer, let's right click on the project itself, go into Properties, and over here let's scroll down, and over here under Build, we can see, yep, here's a checkbox to allow code that uses the unsafe keyword to compile. So yep, let's enable this, and yep, the error is gone. Okay, great. So now in here we can use pointers. For example, we can define an int pointer. And the way we define a pointer is first to type int, and then a little asterisk. So this is an int pointer. Let's call it like int array pointer. And in order to allocate some memory, we can use stack alloc. Then let's allocate memory for an int array with, let's say, 10 elements. And if this is going to manually allocate some memory for an int array, then for example, if we want to read the memory location for this, we can grab the int array pointer, we can cast it down to this type, the int pointer, and let's just print this to see what this says. So let's do a console.writeLine. Let's print out this. Let's just do a toString to convert this into hexadecimal. So toString with format of X. Okay, let's see. And if there it is, we allocated our pointer, our int array, and it ended up being allocated on this exact memory address. Now let's read the entire memory address location. So let's do a simple for int I equals 0, I less than 10, I plus plus. And for this int array pointer, we can access this as if it was a normal array, so just access that one. Let's do a console.writeLine on this one. Okay, let's see. And yep, it's all in zeros, makes sense. But now let's see another thing. So we are allocating with 10, and over here, let's actually read 20 positions. And if you look at that, this did work. Usually, if you try doing this in non-unsafe code, in normal code, if you try to access this array on something bigger than the index, if so, then basically normal C# code would have a bunch of safety, and that safety would stop us from looking beyond the index bounds. If we tried, we would get an index out of range exception. But over here, when working with unsafe code, we don't get that. We can read the memory beyond the array, and doing so, we're basically going to get gibberish. So the first 10 positions, those have been initialized as new int array, so those are guaranteed to be initialized to 0. But these other ones can have really any memory. This memory does not belong to the int array, it belongs to something else. But as you can see over here, the unsafe code does not stop us from accessing it. So even though the int array only has a size of 10, we can go all the way up to 20 and even more. By the way, this is actually the basics for how hacking programs work, things like aimbots and wall hacks. Usually they read memory they're not supposed to, and then interpret it in some way, like for example display an enemy behind the wall. And the pointer itself, this one is also, like we saw here, it's just a position in memory. So we can take this one and, for example, let's increase it. Let's increase by some amount. This basically means we're going to look at a memory location for it, which again is going to let us read a bunch of garbage. So up here, let's read just 10 elements, which without adding this one, we would see everything with zeros. But now, yep, we see a bunch of garbage values. So pointers are really just numbers to a location in memory, and you can increase that number. You can do whatever you want to read a different location in memory. Now the asterisk over here, this one defines a pointer, and then another symbol, the ampersand, that one defines the memory address. So for example, let's make over here a simple struct. Importantly is that pointers need to work with unmanaged memory. Again, the entire concept of managed memory, that's a C# thing. C# automatically manages memory for you. But when working with pointers, when working with unsafe code, we are intentionally not using any of that. So when working with unsafe code, we're pretty much limited to just using unmanaged data. So that is why over here, let's find a struct for some kind of game data. Then inside, let's define some kind of value for some coins, and then maybe a bull is game over, something like this. So now up here, let's say we construct a brand new one, game data equals just a new game data. And now let's define a game data pointer. So this is not of type game data, it's a game data pointer, so game data pointer. And for this one, let's make this pointer point to this structure right here. So for that, we use the ampersand in order to get the actual address in memory of this game data. And yep, so now we have this pointer, and this pointer is going to point to this data. And now, for example, for accessing data inside a struct, for that, we access our pointer. And now, normally, when working with C#, you would do .coins, something like this. But over here, we are working with pointers. And when working with pointers, or when writing some C code, to access a sub-element of this object, for that, we do a little arrow. And then we access, for example, the coins, and we can set it to something. And then same thing for the other one is game over, we can set it to something. So if this is how we can access some members of some data, some type. We grab the pointer using the location memory, and then access those members and do whatever we want to. Then you can also declare pointers as function arguments. So for example, let's make here a function to raise something to the power of 2. So let's make a static function, just because over here we're in the static thing. Let's make it void and call it power 2. And over here, let's receive a pointer as a function argument. So instead of an int, let's receive an int pointer. Yep, just like this. Except, of course, we see an error. We can't use pointers. We can only use them in unsafe contexts. So let's mark this entire function as unsafe. And yep, that does work. And now we want to modify this value. So to modify the value, we access the pointer itself. And then we're going to set it to something. So in this case, power of 2, we want to basically put this value to the power of value. So let's do times equals, just to do the multiplication. And then times equals, again, the value stored inside a value. So not value like this. This is an error. We don't want to get just the pointer itself. Instead, we want to get the data where that pointer points to. So let's put a little asterisk to get that one, just like that. So that inside of here is going to multiply itself by that one, and that will basically do a power of 2. So then up here, let's use it. Let's find some kind of value. So int a equals 5. So just a simple integer. Now call the function, so power 2. But now we need to pass in a pointer, not that itself. If over here we use just a, yep, we have an error. It's telling us cannot convert an int, meaning just a simple integer, just simple value, to int star, meaning an int pointer. So we need to pass in the pointer, which means we need to pass in the memory location, just like this. And if that's it, that works. Now, one interesting thing, since we are working with pointers, meaning that this is going to point to the original position in memory, even though over here we are working with an int, which is a value type, and normally if we made this kind of function and over here we receive just a normal int, with that, if we then multiplied it, we would only be modifying the copy itself and not the original data. But since over here we are passing the pointer itself, if we do a console.writeLine on this one, on A, if there it is, it says 25, so 5 to the power of 5. So the function, this one modified the data on the variable itself, even though it's an int, and the reason is because we're dealing directly with pointers. Then some objects might move around in memory. If you have some kind of managed data, like for example, just a simple managed array, if you have something like this object might go into different positions in memory. So if you want to do something, you can use the fixed keyword, and this one is basically going to generate a pointer. So a byte pointer equals our bytes. And yep, basically this one over here, the fixed, this one is going to generate a fixed pointer to this object. So whilst inside of this fixed code block, we can make sure this byte pointer is valid, but when outside of it, this object might move to a different position in memory. Okay, so that's how you write unsafe code and deal with pointers. Like I said, this is a very, very advanced topic. It is very error prone, so definitely make sure you know what you're doing. Unless you're writing some code in some embedded systems or something super hardcore like that, chances are you really don't need this. C# has a ton of really awesome safety features that are meant to protect yourself. Those are really good, they help you write much more error-free code much more easily. So only disable those when absolutely necessary. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about asynchronous programming. Specifically, we're going to learn how to use the async and await keywords in C#, as well as how to use the task type. Okay, so first of all, what exactly is asynchronous programming? This is how we can have code that executes in a non-linear sequence. Basically, it's how we can have some code pending for execution while some other code is executing. One great example is simply to think about cooking. For example, let's say we want to cook some breakfast. We want some coffee, eggs, bacon, toast, and so on. Now, if we do it in a non-asynchronous manner, meaning if we do it all sequentially, one task after another, then first we pour some coffee, after that's done, we heat the pan, after that's done, we fry some eggs, then afterwards do this, and so on. So basically we do each task to completion one by one until the end. So in total with this, we would spend maybe 30 minutes. But obviously, looking at this example, you can probably see that this doesn't really make much sense. You wouldn't really make your breakfast this way. There's no point in standing around doing nothing while the pan is being heated. You can start some of these tasks at the same time. So the asynchronous method of doing a breakfast is like this. So we pour some coffee, and then we start frying the eggs, start frying the bacon, and start toasting some bread. We start these three tasks at the exact same time. Then while those tasks are making some kind of progress, we continue doing anything else. As soon as the task complete, we get notified and we can do more things. So for example, the eggs get done while the bacon is still cooking. Then the bacon is done while the toast is ready, so we start putting some jam and so on. So basically we start a bunch of tasks, and then in the background we wait for them to complete, and while we're waiting we can do other tasks. So in total, by using this method, naturally we would make it quite a bit faster. Although here, let me point out one extremely important detail. Asynchronous does not mean multi-thread. Meaning everything, all of it, still runs just on one thread. Making something asynchronous just means there's really a pending task and we're waiting for it to complete. So the common example in actual code is doing something like contacting a web server. We make the request, and then we just sit around and wait for that request to return, for the server to actually send a response. Meaning our CPU is not actually doing any extra work on that task. It sends out the request and just waits for it to complete. So always keep that in mind. Making our programs asynchronous helps us keep the program nice and smooth without freezing, but it does not make it multi-thread. Okay, so now that we've seen the theory behind async programming, let's learn the syntax in C#. So for example, let's say we have a function to contact a web server. So here, let's make a void contact web server. And now here we do something that takes some time, so we would make some kind of HTTP request. In order to simulate this, let's use the task.delay. This function basically waits a bunch of time. It's simply going to delay execution. It's not actually going to do any work, it just waits. This one takes some milliseconds, so let's wait for 3 seconds. Okay, so here we're pretending to contact the web server and wait for a response. Let's just do a log here, so console, let's do a write line, and let's print out contacting server. So we're contacting, and then we contact, then let's say by this, the server has finished getting a response, so let's say got a response. Okay, just like this, and for testing, let's run this. Although this one actually quite worked, but let's test. And if that's it, just basically ran both of them at the exact same time. So it didn't actually wait any time. That's because over here, task.delay, note how this one says awaitable and returns a task. So this is an asynchronous function. This task object itself, this is what contains the data for the pending action. If we want to wait until this action completes, then we need to await it. So right before it, we write the keyword await. Yep, just like this. This will basically pause the execution right here on this line until this task ends. And when the task ends, then it continues going on to the next line. Again, remember, this does not make it multi-thread. When we use await, this logic for the task.delay, that one is still going to run on the main thread. It is simply just going to wait until it is completed before continuing. And also here we do see an error. It is telling us the await operator can only be used within an async method. So in order to make this work, we need to mark this function as async. Yep, just like this. So now let's test like this, except it also didn't quite work. We can see it did start contacting the server, but the program just ended before we got a response. So let's make sure we keep our program alive, we keep it running while we wait. So for that, we can just do a while true, just an infinite loop, just so it keeps running forever. Then we can forcefully close it. So like this if we test. Okay, there it is, and contact the server right away. And now after 3 seconds, yep, there you go, we've got our response. Alright, awesome, so this worked. Here we have the main asynchronous syntax. We mark our function as async, and then inside it, when doing some kind of asynchronous work, whenever we want to wait for something to complete, we use the keyword await. and doing so basically it will pause the execution of this function right here, and will only continue after this task completes. However, very importantly, note how up here it did not pause. So down here on this function, when we got to this, it paused and waited for 3 seconds before it ran this line, but up here, we ran this line of code right away, and we went inside the while true immediately. We can actually put a console.log over here just to see exactly, and let's see. And if there it is, it's constantly printing out dashes, so that code is running. This is very important. So we ran this line of code, which in turn started this action and then waited for it to complete. But whilst waiting for this one, the code over here on the main function, that one continued executing. So it did not stop on this function, it continued going on to this one and continued going on forever. So with that, we had 2 branches of code running at the same time, except they were not really running at the same time. Again, this is not multi-thread, we have just a single thread. What we had was essentially 2 pending tasks. So whilst working on the main thread, our code was constantly testing, is this task done? Just doing a quick check, and if not, then just continue running the same code as normal. And then when this task completed, then continue going on to this, it finished this function execution, and everything else ran the same. However, also one very important thing, which is how up here, like we saw, the code does not stop. So we start contacting the web server, and then we continue running some logic. So if we do this, if over here our code does not stop, how exactly can we know when our task has been completed? So in this example, how exactly do we know in here when have we finished contacting the server? When can we actually get some data back? So let's say we get some data, so let's just define a string for the server return data. So you have this, and over here, after we contact the server, let's get some data back, okay? So now the question is, how do we know over here in this code, well, inside of this while, how do we know that this data has been returned? If we just try reading it right away, so let's get some in for some kind of data length. Let's just access the server return data and get the length, just trying to access that object. If we do this, naturally it won't work since the data will not be set right away. It has to actually wait for the server. So if we test this, yep, obviously we get a null reference exception. The data has not yet been returned, so this one is still just defaulting to null. So essentially we need to know when is this task done executing. And for that, we can use the same task type ourselves. So over here on this function, instead of returning void, let's make it return a task. And up here when calling it, let's grab our task. And then inside of this one, we can access all kinds of things. So here we can get a bunch of stuff. And the main one is really over here, these properties, so like is completed. This one is going to be true when the task actually completes. So let's just check for this one. So if the task is completed, if so, then let's get the data length. Let's just do a print on that. Yep, so now while the task has not been completed, this code is not going to run. And when it does complete, then we have our server return data, and now we can run this logic. Also, by the way, alternatively, we could just call task.wait. This one would work, but this would block our main thread. So our code would not keep executing like this. It would stop right here until the task actually completes. Whereas like this while is going to constantly running over and over again until the task completes, and then it's finally going to run this logic. So let's test. And if here we are contacting the server, and after a while we should be able to see, yep, there you go, we've got our length. Okay, great. So here we can see that our function waited until we were finally able to read some data. However, usually you actually don't want to use this method, the method of doing a while true and then waiting for the task completed. Usually the proper way is exactly like we did it down here with the task.delay, meaning we should use the await keyword. Like we saw here, that won't pause the execution of the rest of the function until it completes. So over here, instead of grabbing the task manually and then manually waiting for it to complete, instead of that, let's just await this function call, just like this. And then any code after here, we can assume this function has been finished, which in turn means we do have our return data. So we can get rid of these checks, we don't need them. Just like this, it won't work. So it starts contacting the server and only continues running this code after the server has returned a response. However, again, when you use awake, we need to mark this as async, so we have to do it like this. But if we try this, if we try making main async, if there it is, we actually have an error. And the error is telling us program does not contain a static main method suitable for an entry point. So making this function signature async void main, this is not valid for a main function. However, we can definitely make main into async. We just need to make sure that for the type, instead of void, we return task. And yep, like this, it should work, so let's test. So here we are contacting the server, and we are indeed waiting. And after 3 seconds, yep, we get a response, we get the 4, and everything works perfect. So yep, just like this, it worked. We did not have any errors, because again, the program stayed on this line. It did not continue down until this function was completed. Then when this one is completed, then down here, we can make the assumption this has been set, because we do know this task has completed successfully. So now that we've seen this syntax, let's actually see that breakfast example. So for example, we have our functions to do all kinds of things. So let's do a static async, let's return task, say like cook eggs, and in here let's do a console.writeLine, in order to say that we are starting cooking our eggs. Then let's do the same thing. Let's pretend this is doing something. So let's use task.delay, just wait for a little bit. And let's say the eggs take 3 seconds. Then a console.writeLine saying that our eggs are done. Okay, great, like this. Let's make 2 more. So let's make one for cooking bacon. And for bacon, let's say it takes a bit longer, so it takes 4 seconds. And then finally, let's make toast. And this one is quite a bit faster, let's say 1. Okay, great, just like this. So we have our breakfast functions. And now up here on our main, in order to start running those functions, let's first actually see the sequential non-asynchronous method. So let's first cook our eggs, but let's await it in order to make sure the eggs fully finish cooking. Then let's do the same thing, cook our bacon, and let's also await for it to finish. And same thing for make toast, let's also await for it to finish. So this is essentially going to be our synchronous method, meaning we're going to fully cook the eggs, then fully cook the bacon, and then fully make the toast. So let's see this. And okay, there it is. Eggs are starting to cook. And after a while, eggs are done. Now starting to cook some bacon. And after a while, bacon is done, starting to make toast, and toast is done. So yep, with this, we met our breakfast, but we also wasted a ton of time. We can essentially do all 3 of these tasks at once, assuming we have 2 pans. There's really no need to wait for the eggs to finish cooking before we start cooking bacon or before we start making toast. So instead of this synchronous code where we fully finish one task before starting another one, instead we can start them all at once, meaning they all start cooking right away, and then we just need to wait for all of them to be completed. So instead of waiting it, let's grab the task from that, so the eggs task, and over here task for the bacon task, and finally a task for the toast task. So we have all 3 of our tasks, and again this code is going to run sequentially right away. So we're going to immediately start cooking eggs, immediately cook bacon, immediately make toast. And then after starting all of these tasks, now we do want to wait for all of them to finish. So in order to basically await multiple tasks, we can use inside the task class, there's a when all function. This one takes an array of tasks. So let's wait for the eggs task, the bacon tasks, and the toast tasks. And yep, this one is going to be an awaitable call. So let's await on this, which means the code is going to pause execution on this line until all 3 of these tasks are done. And then down here, we have our breakfast done. So console, let's write line, our breakfast is done. Okay, so yep, just like this, let's test and see. And if right away we can see cooking eggs, bacon and toast, all of that starts and toast ends right away, eggs done, and finally bacon done, and we have the full breakfast done. All right, awesome. So we got our breakfast done, and we made it much faster because we started all our tasks right away, and we just had to wait for them to complete. So instead of cooking each task individually, instead of that, we started them all, and then they all finished. So this is really how async works. You start doing some work, and then while waiting, you can go do other work. Now with all of this, there's really only one thing missing, which is how do we return data from one of these functions? Right now, this is just returning a task, meaning it's actually not returning anything, but we can indeed return some data. So on the test type, we have a generic version for exactly that purpose. Then over here, we use whatever type we want. So for the contacting web server, let's say we want to get a string back, just like this. So instead of setting some kind of field, let's just return our data. And yeah, just like this. So now here, the way that we call this is we call the function, but we want to wait for it to complete. So let's await it. And in order to get results, we really just put it over here. So server return data, just set it equals to that one. And now we can do a console.writeLine on this one. And since we awaited, it's going to pause in this one before going into this one. So this one should have the correct data received from the web server. So let's see. And okay, it's come to the server. It's waiting for a little bit. And after a while, yep, got a response, and response was indeed data. Okay, great. So this is how asynchronous programming works in C#. We have tasks. We can start those tasks right away. And then we can wait for all of them, which will essentially pause the code execution until those finish completing, and then it continues running the rest of the code. Then if we use await on some kind of function, we also need to mark it as async. And when using async, we can either return void, which usually doesn't make much sense. Usually you want to return whatever task you are awaiting. So you usually want to return either task or the generic in order to return some more data. Now, like I said many times, and let me repeat once more, just because it's something a lot of people get confused about, asynchronous programming is not multi-threaded. All of this code right here, all of it is still running just on a single main thread. We're actually going to learn all about multi-threading in the next lecture. Alright, so that's asynchronous programming using async, await, and task in C#. It's how you can keep your program running and not freeze while waiting for some kind of external result to arrive. This is extremely important in order to make sure your applications stay nice and responsive. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about multi-threading in C#. This is how we can create separate worker threads to do all kinds of work on multiple threads at the same time. When done correctly, we can improve the performance of our program by a massive amount by utilizing all the cores to their max. Okay, so multi-threading. Right away, let me say this is a huge topic with many potential pitfalls. This is very much a definition of an advanced topic. Writing properly multi-threaded code is actually quite difficult. It is very easy to make mistakes. So here we're going to learn just the basics, but then do make sure you dive deeper into this topic before you start using it in production code. So let's start with the absolute basics. First, what exactly is a thread? Now, a thread is really just a unit of execution within a process. It does not automatically match up to a core in your CPU. We can technically create as many threads as we want, but usually you want to create as many threads as the processor has cores, and then you want to try to split the workload evenly in order to achieve 100% CPU core usage. That way, all the cores will be busy doing something instead of doing everything just on a single main thread, which is actually how a lot of code runs. And also, I should point out what exactly happens if you create too many threads, or if you have multiple programs, all of them running multi-threaded code. If you do that, then the answer is actually quite simple. The CPU will schedule the threads to run on different cores if possible, and if not possible, then it will simply queue up the threads. So if you have 10 cores and you make 20 threads, 10 of those will be queued waiting for a core to be available to do some work. It won't magically create 20 cores if you make 20 threads. It will use all the cores as much as possible, but naturally it can't use things that don't exist. That as well, like I said, usually first you check how many cores your CPU has, and then you define the number of threads to create based on that. Now here in C#, in order to create a thread to do some work, it's actually quite simple. Now first we define the function where we want to do some work. For example, one very common use case in game dev is doing some kind of pathfinding. You want the main game logic and all the UI and all of that to be running on the main thread. You want that to be super smooth and not freeze while waiting for pathfinding. And then you want to take advantage of all the cores of the CPU to make the pathfinding super fast running at the same time. So for that, let's start by making a simple function. So let's make a static void, call it calculate pathfinding. And now here, let's just start calculating pathfinding. And to simulate that, let's use thread.sleep. And thread, like it says here, exists inside of this namespace, system.threading. So thread.sleep. This function simply keeps the CPU busy for a certain amount of time, let's say for 3 seconds. So basically this is going to be simulating as if the CPU is doing some complex pathfinding algorithm. Let's just do some logs just to see. So console.writeLine, over here calculating pathfinding, and then over here, let's say pathfinding done. Okay, so this is our function. This is the work that we want to do on a separate thread. Basically we want to be running this logic while the main thread is doing something else. So here, instead of manually calling the function, this would just run it on the main thread. So instead of this, let's create a brand new thread. So we do new thread, and now inside we pass in the function we want to call, or alternatively, we can be more explicit. We can construct a new thread start, and inside use our calculate pathfinding. Now this function here takes in a delegate. It has to return void and have no parameters. So yep, exactly the same signature we defined here. Now this is going to construct our thread. So let's define this as our worker thread. So we have this, but just like this, it won't actually run just yet. All we're doing here is just creating and setting up the thread. In order to run the logic, we need to go inside of this one and call start. And yep, now this will start executing this function on that second worker thread. And then after here, we can run some code that is going to run on the main thread. So here, console.writeLine, doing some main thread work. And then afterwards, when we want to do something that depends on whatever result we have in this thread, after that, we can once again use the thread and call the function join. And this will basically block the calling thread, meaning the main thread. It will block it until this thread that is doing some work, until this one terminates. So we call join, and now down here we can run some code on the main thread, whilst assuming that the second thread has completed. So for example, if we were calculating some pathfinding, then over here we could assume the pathfinding has been calculated correctly, and we could use it to move some unit or something like that. So yep, over here let's just do something like this, just print another log, and let's test. And okay, there it is, main thread is doing some work, we're calculating pathfinding, after a while pathfinding done, and main thread done. Alright, awesome, so everything does seem to be working. However, right now, you might also be thinking this looks a lot like what we covered in the previous lecture on async programming. If we replace what you used with the await and async, then this would actually look quite similar. However, like I mentioned in that lecture, async programming is not multi-threaded. In async programming, we were waiting for an external service to do some kind of work, like contacting a web server. All we were doing is really just waiting to get a response back. Whereas here, we are actually doing some work on both threads at once. We can verify that by actually printing some more messages. So over here on the pathfinding, let's do a for to print a bunch of messages. So let's do a thread.sleep and let's do a write line. Okay, so like this. And then on the main thread, let's do pretty much the exact same thing. So over here, we're going to be doing some kind of main thread work. And let's make this one a little bit faster. Okay, so let's do like this. And if there it is, calculating pathfinding, and we can see both the main thread and the pathfinding thread, both of those are working at the exact same time. Again, this is the really big difference. In async programming that we saw in the last lecture, there is really just one main thread. We simply have some tasks that are waiting to be completed, but we don't actually have two threads doing work at the exact same time, whereas over here we do. We can see the main thread is doing work and the pathfinding is also doing work at the exact same time. Whereas if we were just using the main thread without any extra threads, then we would basically be doing this. So this is fully main thread work with no extra threads. And if you look at that, it's first doing the main thread work, doing all of that, and only then starts doing the pathfinding work. So right away you can see the massive speed up difference. We can get literally double the performance by using multiple cores at once. So this here is really the basics of multi-threading. It sounds pretty simple. You create a brand new thread to do some work, then you set it to do a bunch of work, and then it can do some other work on the main thread. So it looks quite simple, but beyond this super basic example, it actually becomes quite complex. One very common problem is what is known as a race condition. That is when two threads are trying to do work on the same data at the same time. So let's actually intentionally create a race condition just to see. So up here, let's define a static int for some kind of resource amount. And then let's make a function that is just going to add a ton of resources. So add resources, and over here, let's just do a giant for, let's say by 10,000, something like that, something super huge. Then let's first grab our resource amount, then we increase it by 1, and then we update the resource amount to this temp resource amount. Okay, yep, so we're really just going to be increasing the resource amount by 10,000. And now up here, let's just create a whole bunch of threads. So let's create a thread array for some kind of thread array, new thread array of, let's say, 10 threads. Then let's go, let's cycle through that array, and let's construct a brand new thread. So just do a new thread and pass in the add resources function. So yep, here we are going to create all of our threads. Then let's simply start executing all of them, and then let's call join on all of them to make sure they all finish. And after this, let's print out the resource amount. So console.writeLine on our resource amount, and just print the resource amount. Okay, so yep, just like this, super simple. We construct 10 threads, all of them running the same function. And on this function, we're going to increase the resource amount by 10,000. So 10 threads increasing by 10,000 means that the final number that we see printed here, that final number should be 100,000. So let's see if that's the case. Let's test. And nope, right away we don't see that. We see 72,000. Let's try again. And nope, now we see 80,000. And now we see 83,000. And now 87,000 and so on. So nope, we do not get 100,000. And every time we run, we actually get a different number. So what we have here is what is known as a race condition. Basically, all of these 10 threads, all of them are running this function at the same time. They're all doing work at the same time on multiple cores. And they're all working on the same shared variable. So what happens is, for example, thread A starts running this line of code. So thread A reads, let's say, 15 resources and stores them in here. But then let's say thread B already ran that line of code. So thread B already read 15. Then thread B incremented it to 16. And then thread B updated the variable to 16. But then thread A, which again has already read the value 15, then thread A is going to increase to 16 and save it again. So because of that, we essentially lost one resource. And it's all because of a race condition. It is because we had one thread just reading some data while another thread was already doing some operations on it. Because they're both trying to execute code at slightly different times, we end up with different read and write values. So that is why the result is always less than 100,000. It is because some resources are going to be lost to race conditions. Now, you can imagine this would be very annoying to the player of the game, losing resources for no fault of their own, just because the threads all ran logic at the same time. That's pretty annoying. So this is really one of the big problems of multi-threaded code. It is very easy to end up with race conditions and mess up all your data. Now, to solve this problem, we have a very useful tool. It's called a lock. And to use it, we write the lock keyword, and then within parentheses, we put some kind of object that we want to work as our lock. Now, importantly, this one has to be a reference type. So if we use the resource amount, we can see an error. Int is not a reference type. So the lock over here has to be a reference type. So usually we just create a basic object. So let's go up here, make a private static, make it of type object, and just call the resource lock. And let's construct it just to a brand new object. Okay, yep, we have this lock. Now, importantly is this lock should be shared, meaning we should not have one lock per thread. That would kind of defeat the purpose. We want the lock to be shared between all threads. So we define the lock we constructed, and down here we use that lock, and afterwards we just open and close our code block. And yep, that's it. And just like this, let's test. And there you go, the resource amount, the total is indeed correct, 100,000. Try again. And there it is, 100,000. Once more, and yep, 100,000. So it always works perfectly. Basically over here, this lock, what this is doing is, like the name implies, it is locking this part of the code to a specific thread. So for example, thread A goes through this line of code, and when doing so, it essentially registers this object as being locked. It is being locked as being actively used by thread A, and then thread A starts running all of this code. And now here's the really important part. If thread A is in the middle of executing these lines of code, if then thread B comes along and tries to grab the lock as well, if so, then thread B cannot get it. The lock is already in use. So thread B has to wait for the lock to become available. It cannot run any of this code until that lock is available. So basically thread A, which has the lock, that one does its thing, reads, updates the value and so on. Then when thread A exits, then it releases the lock. And then thread B sees that the lock has been released. So thread B registers the lock and starts running the logic on that thread. And same thing again, any other thread cannot go inside this code block until the lock is released. So by using the lock, we are making sure that only one thread can be running this code at once. Now, naturally, this does mean that you'll lose the benefits of multi-threading. All threads are waiting for this lock to become available, and only one of them is actually going to do some work. So this is yet another reason that makes multi-threading so difficult. Technically, you can avoid all race conditions by just putting everything inside of lock, but then of course you also have no benefit. So you have to be very clever as to how you use your locks. Use them as little as possible in order to make your code as parallelized as possible. You don't want to overuse them, but you definitely want to use them to avoid race conditions. Basically, knowing what parts of your code need to be unlocked versus unlocked, that is definitely a skill you need to learn in order to write proper multi-threaded code. Now, another potential issue is something called deadlocks. So this is where two locks are each waiting for the other one to be unlocked. So here's an example of that. We've got two locks, then we define two threads. So this thread opens up lock 1, and then inside it tries to open up lock 2, and then this thread opens up lock 2 and then tries to open up lock 1. Then we start the threads and then we join them. So if we call this, let's see what happens. Let's see if our program ever exits or not. Let's just return. Okay, let's see. And if there it is, then our program is basically stuck. The issue that is happening is over here, thread 1, this one immediately grabs lock 1, and then thread 2 immediately grabs lock 2, but then they are both waiting for the other lock. And that is never going to happen because thread 2 is stuck waiting for lock 1, and thread 1 is stuck waiting for lock 2. Both are waiting for the other one to do something, so nothing really happens. So when working with multiple locks, you also need to take care of this. Make sure you don't have interlocking locks. That in turn means that your program ends up frozen. Then another potential issue of multi-threading is simply how it makes your debugging much more difficult. Usually if you have some kind of bug in your code, like for example pathfinding is calculating some wrong path, usually you can just follow the stack trace to figure out exactly what went wrong. You can see exactly what called this function, where the data came from and so on. But when using multiple threads, those will not run in a deterministic fashion. They will run at different times depending on whatever else your CPU is doing. So you can have bugs that appear randomly every once in a while because the threads ran in one specific order. Because of that, it is really difficult to replicate the bug, which in turn makes it really difficult to debug. Yet another potential issue is simply the cost for overhead. So making threads, this is not free. Creating a thread has some sort of overhead cost, both in creating it and in the CPU managing all the active threads. So in some cases, multi-threading can actually end up making your code slower. The CPU might be so busy trying to keep track of all the threads that it actually loses more time than doing some actual work. Like I mentioned, there's no limit. You can create 1,000 threads on a 10-core CPU, but then they're going to run worse than if you just use a main thread because of all the context switching involved. Now, if you want to just do some simple work without the overhead of creating an entire thread, for that, C# has something called a thread pool. Basically, it has a pool of threads that is automatically maintained by the .NET runtime. It efficiently manages all the threads, allowing you to easily reuse them. So you can queue up a bunch of work, and then thread pool also automatically scales up or down depending on demand. Now to use it is quite simple. So instead of creating a brand new thread, instead of that we just use thread pool, and then we just call queue a user work item, and then we just queue something. This one takes in a wait callback. This one is essentially a delegate that returns void but has an object. So over here, let's make some kind of function for that. Let's call it just do work. This one takes an object. And over here, let's print the thread ID. So let's do a right line, go inside the thread, grab the current thread, and grab the managed thread ID. And let's say this one's starting, then do some work and then finished. So thread.sleep for something. Okay, yep. So we're going to do this work on this thread. And now here we can essentially just queue up multiple of these. So let's just go for int I. Let's just queue up 10 of these to do this kind of work. Again, we are not creating threads, we are just queuing up some work to work on the thread pool. And then since we don't have a reference to some kind of thread that we can do on join, let's just do a while true just to stop our program so we can read our code. Okay, let's see like this. And if there it is, we can see a bunch of threads started and a bunch of threads finished. So we can see we did a bunch of work on multiple threads at the same time, and it's doing all of this without us having to manually create and start some threads. So thread pool is really great, but it is really meant for small use cases only. If you want to do some complex work on a worker thread, meaning something that does work in parallel for a long time, for that you should probably use a normal thread and manage it yourself. But for small things, thread pool is super easy to use. Now here we've been talking about C# multithreading, how you can create your own threads to do any kind of work, but if you want to properly use it, you need to make some sort of thread scheduler. So something that keeps track of a queue of work to do, and then each thread pulls something from that queue when idle. But if you're working inside of Unity, you don't actually have to build something like that from scratch. In Unity, you can just use the Unity job system. This one is really easy to use, and Unity handles all that complexity for you. It automatically creates a bunch of worker threads and then manages them. It manages those threads alongside a pool of jobs. So then you just create some jobs and add them to the queue, and the job system will pull some jobs and do some work. This one has a bunch of features. It has tons of safety in order to make sure you don't mess up yourself. So when working with Unity, definitely go ahead and use the job system. It is going to be much easier than manually handling threads yourself. You can look at my video on dots to learn how to use it, or you can check out my complete dots course, which also covers the job system, plus ECS, the burst compiler, and a bunch more. Alright, so that's how you write multi-threaded code in C#. This is an extremely powerful skill to know. It is very difficult to do it properly, but if you can do it, you can literally get 10x performance improvements on the exact same hardware. It has a lot of pitfalls like we mentioned, but also a very huge benefit. So this one is definitely a very valuable skill. Although also, like I mentioned, if you mostly work inside of Unity, then I recommend you use the Unity job system to run that multi-threaded code. The job system has a bunch of features to help you write multi-thread code whilst also avoiding a lot of those pitfalls. Hello and welcome, I'm your CodeMonkey, and congrats on completing the advanced section. We started off with an interesting advanced topic that I actually only started seriously learning recently. It's reflection. I had to learn this myself in order to make the exercises for the companion project. That's how they all work. So now you know how you can dynamically inspect your code and work with it without directly calling functions or reading fields. Next we had a simple but interesting lecture. It's how we can make function extensions. These allow us to extend a type with more functions without having to modify that type itself. So this is really useful when you don't have access to that type, when you don't have access to the source code. Then we learned about static constructors. This is kind of like the normal constructor, but they run just once for the entire class. After that we learned about the type of keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then we saw a lecture on name of. This one helps us get a string name of some type. This is really useful to help us ensure we don't use strings in our code as much as possible. Next we learned about the size of operator. This one lets us get the size of our types. So for example, we can easily see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps us see how much memory our code will actually use. Then we saw a lecture on default. It's a simple and very useful operator to get the default value of some type. You can get the default value of an int, a bool, an object, and pretty much anything. So this is much better than hard coding some default values. After that, we saw a lecture on expression-bodied members. This is a really compact way to write simple short functions. There's no need to write all the usual function boilerplate code. It's basically just a lambda. Then we saw a lecture on records. This is a super simple way to create immutable types to organize our data. Next we'll learn about the null conditional operators. This is how we can easily test for null before doing something, like firing off an event. Then we saw a lecture on the null coalescing operator. This one lets us quickly test against null and return a default value. After that we learned about the ternary conditional operator. This is an excellent super compact syntax for making a simple if. You have just a condition with an if and an else. Very tiny, very useful. Next we learned about the main function in a console app and how to pass in command line arguments. This was a really important lecture because there are so many interesting programs you can build that don't actually need a UI. So just a simple console app that you can control with some command line arguments, just that is going to be an excellent option. Then we saw a lecture on nullable. This is how we can make any type support null, even value types like int or bool. You can make them nullable to support null. So this can sometimes be much better than having to predefine some special value, something like -1. Then we saw a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create any new objects. It's really just basically a pointer, meaning this is insanely performant. Then we saw a lecture on bitwise operators. This is how we can work with individual bits of data. In this lecture, I also taught you the basics of how binary works. Next, we learned about enum flags. This is how you can turn your enums into bitmask, which then allows you to make some interesting combinations. Then we saw the lecture on preprocessor directives. With this, we can give orders to the compiler itself. We can define some symbols and include or not include some code in the compilation. Next, we saw a lecture on the keywords ref, out, and in. These are really useful. They help us get more data out of a function than just the single return type. And they also let us work with types as references, even if they are value types. After that, we learned about data boxing. This doesn't have anything to do with punching people, it's just about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we learned about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields, even if, again, that type does not exist. We can write anything and we get no errors. The validation logic only runs at runtime. It does not execute at compile time. So this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, we can make our own custom type support access through an index, just like a list or array. We can add whatever logic we want and make it read-only or read-write. Next, we saw a lecture on attributes. This is how we can add metadata to our code. That metadata can then represent whatever you want. You can then use reflection to analyze it and do something to it. After that was an interesting lecture on anonymous types. This is a really quick, great way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that was the next lecture on tuples. These are somewhat similar. They also allow you to organize some data without first defining a type. In this lecture, I also covered the differences between anonymous types and tuples. Next was a lecture on using an idisposable. This is a really interesting code block and an interface that helps make sure you don't forget any kind of cleanup code. After that, we'll learn how to create custom override operators. Using these, we can add support to our own classes to do things like addition or multiplication. So we can define, for example, the logic of what does it mean to add two custom player classes together. Then we also define the logic for comparing two custom types. So defining what exactly does it mean to do an equals. Next, we saw a lecture on link. With link, we can easily do query operations on any collection of data. So that can be a list, can be an array, XML, or some kind of database. We can query for some conditions to select just a few elements. We can sort something, do a union, do a join, and so on. So if you're already familiar with SQL, then link was probably also quite familiar. Afterwards, we learned about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop components. Here I also talked about other visual program tools like WPF and .NET MAUI. And I also mentioned how Unity itself doesn't have to be used just for making games. You can make normal applications with it. Next was a lecture on DLL import, library import, how to use extern, and work with the Windows API. This was a great lecture to learn how to interact with external libraries. Then we saw a lecture on asserts and unit testing in general. So with this, you can validate your own code to make sure everything is behaving exactly as intended. Next, we saw a lecture on writing unsafe C# code and working with pointers. Now, this is a very advanced topic. Technically, if you know what you're doing, you can make some very impressive stuff with unsafe code, but C# has safety for a reason. So while we'll learn the basics of it, definitely make sure you use this very wisely. Then we also learned about asynchronous programming, specifically how to use async, await, and task. This is how we can have some code that takes some time, like for example, contacting a web server, and keep waiting for a response without blocking our program. This is extremely important in making sure our program feels nice and responsive. After that was a super important, very advanced lecture. This one was all about multi-threading. This is how we can take advantage of all the cores in the CPU and make them all do work at the exact same time. When done properly, you can get some insane performance improvements pretty much for free, but it is also very, very easy to make mistakes. So this one is very much the definition of an advanced topic where you must know exactly what you're doing. In this section, we learned a ton of very interesting, very advanced topics. And yep, all of that concluded the advanced portion of this course. So congrats again on completing this section and on completing the entire course. I hope you took your time and fully learned absolutely everything in this course. This course really started from the absolute basics of programming, like how code works line by line, and we went slowly, little by little, until learning some very advanced topics. So I hope that regardless of what was your starting point, I hope you learned a lot and you find this course very useful. C# is really an extremely powerful language, and now that you have all this knowledge, now you'll be able to build so many awesome things. You can make games, you can make console apps, you can do electronic stuff, websites, AI, IoT, automation, really just about anything. So I really hope you put all this knowledge to good use. And of course, remember you can always come back to this course at any time. You'll really not expect to memorize all of this. Personally, I Google things all the time myself, and now that I actually have this course in my own words, anytime that I really need to relearn some syntax, I'm just going to come here and listen to my own lectures. So if in the future you need to remember something about C#, just go ahead and rewatch that lecture. So congrats on completing the entire course. I hope you learned a lot, and I wish you the best of luck with your future projects. Hello and welcome, I'm your CodeMonkey. Alright, so congrats on watching through this entire free video. I hope you learned a ton. I really hope you took your time and really focused on learning all the topics in this event section. This one covered quite a lot of very interesting topics. And if you watched this video, I hope you also watch and learn everything from the previous two videos, the one in the beginner and the intermediate sections. If you watch all three, and you took your time to actually truly learn all of this, if so, then now you have an excellent amount of C# knowledge. If you want to try out that knowledge and put it into practice, if so, then you can check out the premium version of this course. The companion project includes the interactive exercise, along with frequently asked questions and quizzes for every lecture in the course. Remember, you only actually learn by doing, so make sure you put what you learned into practice. Now, to continue on your learning journey, if you want a course on making a specific game, you can watch my free Kitchen Chaos course. In there, we build a really nice game from start to finish. There's also a second video on adding multiplayer onto it. For something more intermediate, check out my turn-based strategy course. This one is a really nice turn-based strategy game. It's got lots of actions, enemies, very cool. Or if you're an advanced user, if so, then check out my Unity Dots course. Unity Dots is an extremely advanced but very powerful toolset. It can literally help you write code that runs 100x faster. Or in general, for Unity, check out my Ultimate Unity Overview course. That one covers over 70 tools and features that Unity has. Alright, so thanks for watching, I hope you learned a ton, best of luck in your learning journey, and I'll see you next time.